Hi, students of Miami High, and welcome to a quick science demonstration of the Sun-Earth-Moon system using this model. Just a few features of the model to start with. Obviously you can see the three important heavenly bodies. We've got the Sun, the Earth and the Moon. We've also got the capacity to show orbits. So as you can see, the Earth is moving in orbit around the Sun. It's also rotating. It's also spinning itself around its axis. Interestingly, the Earth is tilted at an angle of 23.5 degrees, perpendicular to the axis of its revolution around the Sun. You can also see from this model that we're happy with this idea of day and night, because approximately half of the Earth is in light and half of the Earth is dark pretty much every time you circulate. Okay, in a second I'm going to ask you to pause the video and just have a little think about the accuracies and inaccuracies of this model. What's accurate and what's inaccurate about it. But first I'd like to talk about the seasons. So if we look at this situation, you can currently see that Australia is at the bottom part of the tilt, so it's not receiving any direct sunlight. This would mean that it is winter in the southern hemisphere. As the Earth continues to orbit the Sun, and to take Australia out of nighttime, I'm just going to have to move it around. You can see now, I'll just get the moon out of the way. You can see now that Australia, because of the 23.5 degree tilt of the Earth, is receiving more direct sunlight. That would make it summer in the southern hemisphere. So when you consider the accuracies and inaccuracies of this model, you might think about how well it demonstrates the seasons. Okay, so I'm going to ask you now to take a second or two to consider accuracies and inaccuracies. Pause the video, and then once you've thought about it, unpause. Okay, welcome back. And let's have a think about some of those accuracies and inaccuracies. We call this a heliocentric system, which would put the Sun at the centre of our solar system. And given that the Earth is currently orbiting the Sun, that would be an accuracy. That would be accurate. The sizes, well, they're not to scale, and the distances are certainly not to scale, but you can see that the Sun is the biggest, the Earth is the next biggest, and the Moon is the smallest. Not wonderfully accurate, but at least they're in some kind of proportion. The Earth spins on its axis, which is fine. The axis is at 23.5 degrees, as we spoke about, and you've got that 12-12, that half-half lighting of the Earth, which would make it an accurate model. Then you've got to think about the inaccuracies of the model, why it isn't quite the way that we'd find it out there. Of course, we spoke about the size. Okay, this distance in real life is actually approximately 150 million kilometers. And the Moon, were it to be to scale, is a lot closer to the Earth. It's not an awful lot different when you think about that huge amount of space, and the sizes are wrong too. The orbit of the Earth, in this case, and the orbit of the Moon, you can see is pretty much a perfect circle. That isn't the case in real life. In real life, they are both ellipses. The last thing I'd say are two things really about inaccuracies in this model. Firstly, of course, there are metal poles holding the Earth and the Moon, and of course the Sun's sitting on this great big plinth. In real life, you would have to think about gravity holding those bodies in orbit and in space. And then finally, of course, to avoid a misconception, in real life, the Sun shines in all directions, not just through a hole, but obviously we'd like this to be a model where we can show things like solar eclipses, where a shadow is thrown over certain parts of the Earth, and in those areas you wouldn't be able to see the Sun. And that would depend on the distances being right, the Sun being 400 times bigger and the Moon being 400 times nearer. But we'll talk about that in time. Okay, I hope you got some of those accuracies and inaccuracies, and I hope that building your models to show the seasons is going well. Thank you very much for looking in.